Welcome back to Huawei Routing and Switching Elite Training for HCIE. Today topic we are going to discuss on OSPF. Let's start our part 3.
A no summary. So in total there are 4 different types of stop areas. We have a stop no summary, NSSA, and also NSSA no summary. So what's the difference between all the 4 different types of the stop? I'm going to draw it out to explain what's the difference between the 4 different stop. Right now, over here, I have a routers connecting 1, 2, 3, and 4. Let me group. Okay. So over here is my area 0. So I have another 4 more areas. So over here I have area 1, area 2, area 3, and also area 4. Let me add 4 more routers. So in total right now I have 5 areas. I'm going to show you the difference between all the 4 different stop areas. Okay, so let me change my color. Alright, so let's at the first one, area 1, we define as a stop. Area 2, stop, no summary. And area 3, NSSA. Area 4, NSSA, no sum. Okay, okay, these are the 4 different areas, area 1, 2, 3, and area 4. So first, let's look at the first one. So for the area 1, is are the stop areas. So previously we're going through all the 5 LSA type. Let's have a look. Let's say right now in area 1, I using the stop areas. So LSA type 1, type 2, and type 3 be allowed. And LSA 4 and 5 is not allowed. So for area 1, when you define as a stop areas, you should still see that I have LSA type 1, type 2, type 3, but not type 4 and type 5. So in this case, when area 1 is within the stop areas, how the routers inside go to the external route? So over here, when you define as a stop, you get a default route. A default route pointing to your ABR routers. So this is your ABR. So the difference here for the normal area and the stop areas, under the stop area they will going to filter the LSA type 4 and the type 5. When you have an area 2 using the stop no summary, I allow LSA type 1, type 2, that's all. So LSA 3, 4, and 5, you will not allow. You'll be filtered. Okay, LSA 3, 4, 5. When you have a keyword no summary, LSA type 3, 4, and 5, you will not allow. But still, ABR will give you a default route as well for you to go to the external route. So I still have another one called default route pointing to the ABR. So these are the stop and the stop no summary. So what happened? What's the difference between the stop and the NSSA? NSSA we call it as a non-so stubby areas. When non-so stubby areas, it means that when I'm the stub areas, but I still can perform import route. Okay, so even those are inside the stub areas, but I still can perform the import route. This is called as a NSSA. So in the area 3, when you perform as a NSSA, I should have a LSA type 1, type 2, type 3, and a type 7. I will not have any type 4 and 5 because I insert the stub. But right now, it's a non-so stubby areas. Whatever I import, when this ASPR within the NSSA, they will convert your LSA 5 to 7. So this is the ASPR when they convert the LSA type 5 to become a type 7. And the type 7 is only happened inside the NSSA areas. So it means that when the ABR receive the LSA type 7, they will convert back to the LSA type 5. They'll convert back to the LSA type 5 back to your transit areas, area 0. And also, for the internal routers inside the NSSA, for them to go to the external route, you also will get a default route. Still get a default route. So these are the difference compared to the stub and the stub no summary. So you still get a default route pointing to the ABR, go to the external route. So in the NSSA, they also filtered the LSA 4 and 5 will be filtered as well, but they allow 1, 2, 3, and 7. And the last, as an area 4, NSSA no summary. So this no summary will be similar to the stub no summary. So it means that they are filtered the LSA type 3, 4, and 5. They allow 1, 2, and 7 plus a default route. So also they can perform the import route and pointing a default gateway to the ABR. So LSA type 3, 4, and 5, they are all not allowed. So same thing, the router's ASPR will convert the LSA type 5 to become type 7 and send to the area 0 as a type 5. So these are the 4 different type of the stub areas. We have a stub no summary, or we call it as the totally stub NSSA, or a totally NSSA areas. So in total, they have 4 different stub areas. Alright, let's come back to here. So that's why over here you mentioned describe the route to the destination outside the AS. NSSA LSA are generated by an ASPR and advertised in the NSSA only. So this you need to be aware of. Okay, let's have a look for the next page. So for the next page is about the option field. Within the option field can be contained in each hello packet, a DT packet, or the LSA. An option field allows communication between the routers, supporting the optional performance. Let's have a look for the first option. It's called as the ADN. ADN is preventing loop when you perform the MPLS VPN. It's a layer 3 VPN. Then you need to using the DN bit to preventing the loop. So this we're going to cover when we touch on the BGP VPN. And for the second, support the opaque LSA, the O. The O bit over here is only used when you perform a MPLS TE. You need to enable the extra LSA to support. So this LSA, they will, when you enable the O bit over here, they're going to support the LSA type 9, type 10, and the type 11. So in this elite training, it's more on the enterprise. We are not covered on the traffic engineering, but it just give you an idea that when the O bit available, you add on 3 more LSA, type 9, type 10, and also a type 11. So for the DC bit, a DC bit is only happen when you perform a on demand. So as we know that within a OSPF, they will keep on exchanging the hello packets. When you enable the on demand link, it means that I will only use it, I will send the hello. When I'm not using, I will not send the hello packet to doing the keep alive. This is on the DC bit. And the ENA, the EA bit over here, the EA bit is to support the LSA type A. Let's say you are using LSA type A, this external attribute LSA will be enabled. And the MP bit, this MP bit is only using when you perform NSSA. When you perform the import route, the M bit it will show that it's 1 to tell that the ABR to convert the LSA type 7 to become LSA type 5 when they translate back to the backbone areas. And for the MC, they support the multicast, and the E bit over here is to provide that, let's say you have a external route, it means that you have a type 5 and they support the multi topology OSPF. So these are all the option field that we can modify, and also communication between the routers support on this optional field. But always remember the E bit and the EN and P bit you always use when you're having the import route of the MP bit when you perform the NSSA areas. You will see that this bit, option bit, will be 1. The rest will be just optional. Alright. So after the OSPF basic concept, let's have a look right now for the how the neighbor relationship set up between the two different routers. So as you still remember, I mentioned before on when two routers they're going to perform the OSPF neighbor relationship. So they're always on the first they're going to on the down state, they go to the init stage. From the init stage they go to the two-way state. So let's this example over here. I have a R1, I have a R2. So first R1 they're going to send the hello packet to R2 to doing the initialization, and R2 will send back the hello packet back to R1 with the router's ID information, and the third hellos to perform a two-way stage. For the two-way state, it means that I know where is my neighbor. So this one we call as a neighbor relationship. Just using one packet, we call as a hello packet. The hello packet to say hello to each other. So after they form the two-way stage, the hello packet is still continually sent every single 10 seconds or 30 seconds. Is based on what is your network type. So this one is a neighbor relationship setup. For the adjacency setup, they need to going through the start, exchange, and also go to the loading and a full state. So for the first packet, they under the start stage, they will send a DD packet, a database description. So under the start stage, they're going to select a master and a slave based on the router's ID. And to select which sequence number we're going to use. So whoever have a highest router's ID, in this example R2 have a highest router ID, I will become the master. So you can see that the first DD packet for the R1 send the DD packet with the sequence number 552A and R2 send as a 552A. So when they have two different sequence number, so the slave always need to follow a master sequence number. So in this case, when you see that when they go into the exchange stage, the sequence number they're going to use start from 5528 because of R2 as a master. So you can see over here they have I, M, and also the MS. So the I bit over here, it means that they're performing the initialization to initialize who will be the master and or the slave. And the M bit over here is to tell you that I have more DD packet to be sent. And the MS bit over here is to select who will be the master or who will be the slave. So these are the three bits when they first send the DD packet to perform the selection, the election of the master and the slave. So in this example, R2 you become the master, R1 it become the slave. So this one, the slave have to follow the master sequence number 5528, 5529, 5529, and so on. So the second database description, the exchange, you will not see there are no more I bit anymore because they start to exchange the full database description to check what LSA information I need to request. So in this case, when we're up to the loading stage, they will send the LS request, LS update, and the LS acknowledgement between the two different routers. So if let's say on the exchange stage, they detected the database description are the same, they will just direct from exchange going to a full stage. So they do not need to perform the link state request or the link state update. So over here we have two different type of relationship. Just now we're going through the neighbor. Another one is called as a adjacency. Adjacency relationship, it means that they already exchange all the LSA information. Okay, exchange LSA information. When you look back just now on the neighbor relationship, they will just exchange the hello packet. They have no LSA exchange. Okay, take note on this. So adjacency, they exchange LSA. So these are the two different relationships that we have in OSPF. One is on the two-way stage, and the other one as a full stage. Two-way stage, a neighbor. Full stage as a adjacency relationship.
Thanks for watching. Please do not forget to subscribe to our channel.